Chapter 3, AP Computer Science, Part 2. So when we're declaring subclass objects, the pretty super cool thing is that this is where polymorphism, where the rubber hits the road. And you can have a reference that's a superclass reference, like student, that references an object of the subclass. So notice we used to have what you see in line 1 here of this declaration, student S equals new student, where your reference type student was the same as the constructor that was being called on the right hand side of the operator new. But look at the next line down, where our reference type is student, but it's referencing an object of grad student. That's okay, that's polymorphism. Because of the is a relationship, grad student is a student, this works. So student U equals new undergrad, undergrad is a student, and so that works. It is not valid to go the other way. We can't have a grad student reference referencing an object of the student class. That doesn't work, but we can have a superclass reference that references an object of the subclass. Take a look at the following. Int student num equals s.getID, and int undergrad num equals u.getID. There's a problem there. Think about it for a minute and why that might cause a problem. Did you get it? With the student, with the S reference that references an object of the student class does not have a getID method in it. The getID method only exists in the undergrad class. So that is why that's a problem. Let me just go back for a second. Where's our getID method? GetID is in the grad student. Excuse me, I have both of those wrong. The GetID method on page 134 is in the grad student class, not the student class, not the undergrad class, so both of those will not work. So polymorphism is a mechanism for selecting the appropriate method for a particular object in a class hierarchy. Polymorphism technically means many forms, and I like to think of it as a chameleon, that when you put your chameleon on a green leaf, your chameleon turns green. When you put it on the desert sand, it turns desert sand colored. Your superclass references can change based on what type of object they are referring to. The correct method is called because it's always the object type that determines what's being called and not the object reference. So when your program is running, the correct method selection will occur. There are two types of binding. There's early binding, which happens at compile time, also called static binding, and there's late binding, also known as dynamic binding, that happens at runtime. And what is binding? Binding is picking the right method. So what object or what reference is calling this method? That's known as binding, which method will be called. And so when that happens at compile time, that's known as early binding. And when it happens at runtime, that's known as late binding. In the case of method overloading, the compiler selects the correct overloaded method at compile time by comparing the method signatures. In the case of polymorphism, it's what is the actual object type will be determined at runtime. So which method will be called will be determined at runtime and not at compile time. So let's look at the examples on page 138 and 139. If we look at example number 1 on page 138, we're looking at we have a student reference S equal to null, student reference U is going to be an undergrad, student reference G is going to be a grad student, and then we print our student statuses, G for grad, U for undergrad, and N for neither. We accept some user input, and if the string equals G, we're going to set our student reference equal to the grad student object. If it equals U, we're going to set it equal to the undergrad. Otherwise, we're just going to create a new student. And then whose method does s.computeGrade reference? We won't know that until runtime. We won't know that until runtime, and so that's known as late binding. Type compatibility, if you want to reference a method that is a method in a derived class, but you want to reference it with a superclass method Take a look at page 140. At page 140, we're going to get a compile time error if we try to reference int x equals s dot get ID. Because the get ID method does not exist in the student class, it will result in an error. Look at int y equals g dot get ID. Because the get ID method exists inside the grad student class, that'll be okay. So that's legal because with early binding, that's going to be fine. With the get ID for the student reference, that's going to cause a compile time error. We can get around that error by casting the reference. It's known as a downcast. If we say int x equals grad student s dot get ID, we are casting that reference to a grad student first and then calling the get ID method. Notice the parentheses. We not only need the parentheses around the typecast, the grad student, but we also need parentheses around the reference. That's because the dot operator has higher precedence than the cast, and so we have to force it to do the cast first and then reference the get ID method. And that will get around our problem of a compile time error that would be okay if we went into late binding, but at compile time, at early binding, it's not okay. So take a look at page 141. This is where I snag these type rules for polymorphic method calls. If we have an example, A is our object dot, or excuse me, our reference dot method, and we're passing parameter B. The method selected will be the type of A at runtime. The parameter B must be the correct type at compile time. So if you look at a declaration like superclass A equals new subclass, that means that the method must be found in the superclass. If it's not, then you need to do an explicit cast on the method to make sure that A is of the actual type at compile time. So for a polymorphic method, at runtime the actual type of A is determined in the subclass in this example, and the method is selected from the subclass. This could be an inherited method of the superclass with no overriding method. That would be fine. The type parameter B is checked at compile time, and again, you may need to do an explicit cast to make sure this is correct. A class cast exception is thrown when the programmer attempts to cast an object to a class of which it is not an instance. So that's where the instance of operator will come into play, that you might use instance of to check and make sure that you've got the right object type before you try to call a method that could throw this exception.